Hi everyone, my name is Chamita Okta. I am a mechanical engineering student in Sampurna University. So in this video, I would like to present about my experiments, which is related with heat transfer, thermodynamics, and fluid. This video will show you about the preparation of each experiment that consists of the illustration of the experiment and the components needed. Then the assembly and the experiment are shown in the other videos and you can access it in the description box. Then I will conclude the experiment and give the feedback of this class Senior Mechanical Lab by Mr. Jati. So this is the preparation of the experiment. First is heat transfer. As we can see, figure shown is the illustration of the heat transfer experiment. These experiments need fan, heater, metallic specimen, anemometer, thermocouples, and sufficient paper board that act as a wind tunnel. All of these tools are purchased by online except the fan. Then for the planning of shipping, it is up to the online store such as Cepat, GNT, etc. Moreover, there are some additional components that is purchased by offline in order to save the money, such as seal tape, sealant, battery for the thermocouple, and paper board. The experiment design steps are: first, prepare all the needs. Second, build the wind tunnel using a paper board and set up all the needs as illustrated in figure shown. Third is heat the specimen by using a mini electric heater until the specified temperature. Fourth, turn on the fan and make sure that the flowing air is hit at the top surface of the specimen. Fifth, place an anemometer in the wind tunnel so it measures the velocity of the wind that comes out from the fan. And sixth is place the thermocouple in some points in the specimen and in the surrounding to measure the temperature. And the last is record the data and analyze. Second experiment is thermodynamics. As shown, here is the illustration of thermodynamics experiment. This experiment needs a chamber, heater, thermocouple, and pressure gauge. Just same with previous experiment, some components are purchased by online and some by offline. To make the holes in a chamber, I use a metal tools that is heated by the fire in the stove. And the steps to do this experiment are: first, prepare all the components needed. Second, make 2 holes in the box and 2 holes in the cover of the box. Third, place an electric heater inside the box and put a small hole for the cable of the electric heater so that it can be connected to the power supply. And then seal the excess hole area by the sealant and tape. The other hole is used for the control of the heater scale of the heater. And fourth step is install the thermocouple and the pressure gauge in the cover of the box. Fifth is close the box and make sure to seal any critical leakage point by tape. This is very important to avoid the air coming out from the box. And the last is turn on the heater and check the measured temperature and pressure periodically and record the data. The third experiment is related with fluid. Here I show the illustration of this fluid experiment. So the components needed for fluid experiment are a chamber, electric heater, pressure gauge, and flow meter. Then the additional components needed are tape and plasticine to seal the holes. The components are mostly same with other experiments, so its purchasing component and planning of shipping are also the same. The steps of this experiment are: first, prepare all the components needed. Second is make the holes for the cable of the heater, thermocouple, and flow meter. Third is turn on the heater. Fourth is check the thermocouple and flow meter periodically. And last is observe the movement inside the flow meter and analyze by changing the inlet of the flow meter. Here is the list of purchased product with total of around 1 million rupiahs including the shipping. Then the assembly and experiments are done in the other videos, which you can access it through the link in the description box. The working principle of the experiment related with heat transfer is convection. Convection is a heat transfer between a surface and a moving fluid at different temperatures. It requires the presence of temperature variation in a material medium. So the experiment used Newton's law of cooling, which is heat flux equal to convection coefficient times temperature of the surface minus temperature of the ambient. And the convection coefficient can be obtained by calculating the Reynolds, Prandtl, and Nusselt's number in laminar flow over a flat surface. Second is the thermodynamics experiment. The working principle used is PV equals to nRT, where P is pressure, V is volume, N is amount of substance, R is ideal gas constant, and T is temperature. This formula proves that pressure and temperature has proportional value, which is when temperature increases, the pressure axis is bigger, and vice versa, when T decreases, the pressure decreases. The third experiment is about fluid dynamics. Here the formula used is volumetric flow rate principle, which is V dot equals to Q equals to dV over dt, and this is the rate of volume change over time, and the V is the velocity of the flow and A is the cross-section area. By using this working principle, we can see that as area changes, then there will be change in volumetric flow rate proportionally. This is the result of heat transfer experiment with different heater scale and velocity of the fan. Firstly, I want to say that there might be error comes for the thermocouple, since the display in the thermocouple shows number that changes quickly. So in this data, the number is taken at the temperature around it. Then as we can see in this table, when the flowing air hit the plate at the bigger heater scale, it will result bigger ambient temperature and temperature in both points of the plate. For example, when 2.5 meter per second of flowing air velocity hit the plate and heat it up by 300 degrees Celsius of heater scale, the temperature one shows 163.9 degrees Celsius, while when the plate is heat up by 250 degrees Celsius, the temperature one shows 138.3 degrees Celsius. So we can see the differences. The second comparison is when the velocity is changed. For example, when velocity is increased to 3 meter per second, the temperature one heated by 300 degrees Celsius of heater scale shows 137 degrees Celsius. From here we can know that when the velocity increases, the Reynolds number will increase too, and when the Reynolds number increases, the Nusselt number will also increase. Thus, the convection coefficient will result bigger. Now we go to the analysis of thermodynamics. My experiment for thermodynamics was not working. As I explained, this experiment utilizes the ideal gas equation, which is PV equals to nRT. So when the temperature increases, the pressure increases. This experiment is made by one box that consists of heater inside. So the heater heats the inside the box and measure the temperature inside the box by using thermocouple and measure the pressure by using pressure gauge. And during this experiment, the thermocouple displays the temperature is increasing over time. However, the arrow needle in the pressure gauge is not moving. Therefore, it may be caused by several cases. First is the leakage in the box, so there is air moving out from the box and cannot be measured by the pressure gauge. The second cause is the box itself. Perhaps the box is not resistant to such heat, therefore the cover of the box is melted and perforated. When I did the experiment with bigger box, its cover still melts. So I directly opened the cover box and see lots of smoke coming out. With this incident, it can be concluded that there is no leakage and student must have proper box. The third case is perhaps the pressure in the box is very small, so the pressure gauge cannot record it. Next, we move to the analysis of fluid dynamics experiment. As I explained before, this fluid dynamics experiment utilizes volumetric flow rate principle. Hence, the student will see how the flow moves from higher pressure to the lower pressure. And in this experiment, the flow from high pressure is from the box that is heated up by the heater, and the lower pressure is in the surroundings. Tools to measure the air flow rate is flow meter. So unfortunately, I don't record the experiment about fluid dynamics. Actually, my experiment doesn't work. It perhaps because of the pressure in the insulated box is very small, so there is no flow generated. And of course, because of that small flow, the float in the flow meter doesn't move upward. So the conclusion is there are three experiments which is about heat transfer, thermodynamics, and fluid. I success to do the experiment about heat transfer, and about other it doesn't work. So for heat transfer experiment, I learned that velocity of the moving air that heat to the hot plate has effect to the convection coefficient. And for thermodynamics and fluid experiment, I learned that when we want to measure the pressure inside the box must be fully insulated. Otherwise, the measurement cannot be worked. Besides, if we want to measure something, make sure that our experiment fulfills the minimal and maximal range of that measurement in order the measurement can record our experiment. And for the whole class, I can know what tools to measure something and learn to use the measurement that I have never used before, such as thermocouple, pressure gauge, and voltmeter. Lastly, my opinion about this class is interesting, so we can choose the tools and do the experiment independently in our house. Then, as we know that the experiment in the campus has already prepared the tools, so we only use it without knowing the price. However, in this class, we can consider the tools that we want to use and manage the money to buy the tools. That's all from me, thank you.